Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Richard je gutangira urusaku rwanyu mu rugabanya. Oragiye? Mwari muri kugana. Hello dear students of Senior 5. Just want to invite you once again to this unit number 11 of lesson number 3. Remember we had talked about the titrations and we did some of the experiments, but theoretically, and we looked at how these titrations are done, and we were able to use the results from the experiments to interpret and get the solutions for those calculations. So here again, Senior 5, I'm just excited to be with you once again. So in this unit number 11, we'll be looking at the calculations involving simple acid-base reactions. By the way, if you remember very well, some of these reactions, because it is simple acid-base reactions, it's like we are just on removing, just recording some of the information that we looked at in Senior 3. So it is not something that is very new. The formula that we are using are the same. So in the simple acid-base reactions or titrations, we are only required to have a calculator. Make sure there is a calculator with you. You have a calculator. And 2, you will need to have a periodic table. It may be very useful once you have that periodic table. Please get ready, and then we move on. So what we are just going to look at, we'll be able to look at the calculations involving concentration of different solutions. We'll determine the water of crystallization using some questions. Theoretically, we'll be able to determine the relative atomic mass. So meaning, when we are looking at these objectives, they are actually even the applications of these titrations. We'll be able to analyze the percentage purity of drugs in pharmaceutical industries. So when we're looking at the analysis of the percentage of the drugs in the pharmaceutical industry, that is another application. So we need to look at that as well. And by the end of the lesson, we'll be able to look at some of those questions involving the following that we have mentioned. So this is question number 1. In order to determine, I ask you, we are just going to read together the question so that we can interpret the question. In order to determine the concentration of hydrochloric acid, 25 cubic centimeters of 0.1 mole sodium carbonate. So you are having 2 substances reacting, sodium carbonate, were titrated with dilute hydrochloric acid of unknown concentration. 25 of hydrochloric acid was needed for complete reaction. Calculate the concentration or molarity of hydrochloric acid. What are we required to do first? You need to write the equation for the reaction. So you're having sodium carbonate. This is question number 1. You're having sodium carbonate reacting with the hydrochloric acid, aqueous. The reaction, you have to remember these reactions. This reaction gives carbon dioxide, gives the salt, sodium chloride, which is aqueous, plus carbon dioxide, which is the gas, plus the water, which is the liquid. You need to remember that the equation has to be balanced. dear students, remember, you start with the equation and then balance that equation. So you need to balance that equation by just putting a 2 there. So this helps you to know the quantities that are reacting, the ratios. This is 1 and this is 2, so that is the mole ratio. So every quantity of sodium carbonate that is reacting, then the hydrochloric acid is twice. So what is the data that we need, that we have? We are just going to look at the volume. I'll just call it VC, which is the volume of the carbonate. What is the volume of the carbonate? 25 cubic centimeters. So you need to first identify the data that you are going to use. What is the molarity? So this one I'll call it molarity of the carbonate, MC, which is 0.1 molar or moles per liter, because this is the molarity. The volume of the acid, what is the volume of the acid? 25 cubic centimeters of the acid reacted or were needed for complete reaction. So we have, this is 25 as well. So do we have the volume? We are asked to calculate the molarity of the acid. So this is what is needed. So once you have the data like that, then you are safe. The rest become very simple. So now, what do we start with? After getting all this data, where do you start from? You need to start from a standard solution. That is a solution whose concentration is known, and that in this case, it will be sodium carbonate. So we need to determine the moles of sodium carbonate. Moles of sodium carbonate. The number of moles of sodium carbonate will be equaling to the molarity. Remember some of these formula, 0.1, that is the molarity, times the volume. What is the volume? It is 25. Then divide the volume must be in liters. So we multiply that one by 10 to power negative 3. That is the same as dividing by 1 liter, which is equal to 1,000 cubic centimeters. So this one will be equal to 2.5 times 10 to power negative 3 moles. So these are the moles of the carbonate. Now, we need the moles of the, how do we get the moles of the acid that reacted? So looking at the question here, the moles of the acid, moles of HCl, that is the acid, will be the same, will be, because this is twice this. So that means we are going to multiply it by 2. So we are going to say this is 2.5 times 10 to power negative 3 times 2, according to the reaction ratio. We are multiplying by 2, because this is twice this. And what do we get? This is what we are just moving on to get. So we have 2.5. Here is the calculator. We need to press the calculator together to see what we are getting. So we have 2.5 times 10 to the power of negative 3 times 2. So what do we get? That is 5.0 times 10 to power negative 3. That is the answer that we have. 5 times 10 to power, these are the moles of hydrochloric acid. But remember, we are asked molarity. So how do we get the molarity? After getting this number of moles, we need to know that if we are to get the concentration, that is the concentration that will be equal to the number of moles, so that is moles over volume, and the volume must be in liters. So meaning that we are going to get this number of moles, that is 5.0 times 10 to power negative 3. We are dividing by the volume. What was the volume? 25. So we have 25, and we said it has to be in liters. So times 10 to power negative 3. So we are having this one and this will cancel. So you'll have 5 divided by 2.5. So that is what we are just going to look at. 5 divided by 2.5. Just get 5 divided by 2.5. So what do you get? No, it is 5 divided by 25, sorry, not 2.5. That is 5 divided by 25. 5 divided by 25. 0.2. 0.2 molar, or you can say 0.2 moles per decimeter cubed. This is the molarity or the concentration. So you need to remember that. So we just go to the next question. It is still determining the concentration. So you have to make sure that this one is the same as that. If you have the same idea of what we have done here, so this one becomes very simple. Sulfuric acid was titrated against 25 of 0.2 molar sodium hydroxide. So you need to note that 25 of 0.2 molar sodium, that is the number, that is the volume and molarity of sodium hydroxide. So it is reacting with sulfuric acid. And this gives sodium sulfate plus water. The equation, I remember I said that is what we need to start with always. This equation is balanced. I think when you look at the equation here, the hydrogens, there are 2 here, there are this, so we need 2 here to balance that equation. So after getting this, you have the volume of the base, sodium hydroxide. What is that volume? That is 25 cubic centimeters. What is the molarity of the base that we have? 0.2 mole per decimeter cubed. 0.2 mole per decimeter cubed. So after getting, this is the information, you need to first put down the data because it is very important. Once you extract the data from the question, then it becomes very simple. So you look at the volume of the acid. So the volume of the acid that is required now is, it was found that 23.2 of sulfuric acid was required for complete neutralization. So that is the volume of the acid, which is 23.2 cubic centimeters. Molarity of the acid, it is also what is required. Calculate the concentration. Concentration is the molarity in moles per liter. So this is the same as we have done. We start with the known. This is a standard solution because its molarity is known in a given volume. So we are starting with the moles. Moles of sodium hydroxide. This will be equal to molarity, that is 0.2 times the volume divided by 1,000. So if I divide by 1,000, it is the same as this. So we need to put the calculation, the workout together with the calculator. If you have 25 times 10 to power negative 3 times 0.2, what do you get? That is 5 times 10. This is the same as 5 times 10 to power negative 3 moles. So after getting the moles of the sodium hydroxide, when you look at this reaction, we have 1, this is 2 here, and this is 1. So what does that mean? That the moles of the acid will be a half moles of sodium hydroxide. Are you seeing that, students? You need to consider. That is why balancing the reaction is very, very important as far as these calculations are concerned. So now, after getting that, we are going to get the moles of the acid that reacted. And we get that according to the reaction. Moles of sulfuric acid that reacted will be equaling to a half, what is 5 times 10 to power negative 3 divided by 2. We are dividing by 2. So what do we get? Divide your answer that you've got by 2. 2.5. This is 2.5 times 10 to power negative 3 moles. These are the moles of the acid that reacted. We need the concentration. How do we get the concentration or molarity? Concentration, as we said, is equal to the number of moles from the previous. Moles divided by the volume, but the volume in liters. So we are getting the moles, which is 2.5 times 10 to power negative 3, divided by the volume of the acid. This is the volume of the acid. 23.2 times 10 to power negative 3. These two cancel out. So we have 2.5 divided by 23.2. Our calculator is at work now. So we have 2.5 divided by 23.2. What do you get? I have 0.1. What do you have? Probably that is what you have if you pressed the calculator very well. So that gives us 0.1 mole. That is the molarity. Now, this is what we are asked for, the concentration. We just move on to the next question, number 3. Is it different from what we are doing? I think it is not, because if you look at the question, you'll find out, you realize that what we need is the reaction. And once the reaction is given to you, then it becomes very simple for you to work out. So let's proceed and try. For neutralization, 25 cubic centimeters of phosphoric acid required 28.7. So we are having 28.7 of sodium hydroxide. Of concentration, 0.15. So that is the concentration of sodium hydroxide. So you have phosphoric acid. This is question number 3. This was question number 2 from here. So the question number 3 is phosphoric acid combining with sodium hydroxide to give sodium phosphate. This is sodium phosphate plus the water. You need to balance the reaction. That is very important. The sodium ions there, and you'll have water molecules. So this is aqueous, sodium. This is the liquid over there. So you have sodium and phosphoric acid. We are looking, what is the concentration of phosphoric 5 acid? So we are asked, volume of this acid is equal to 25 cubic centimeters. You have the molarity of the acid. What is the molarity of the acid? That is what is asked. So that is the question. You need to find out the volume of that acid. So what about the data for sodium hydroxide? Is it given? You need to first extract that one from the question. So you need to find the volume of the base. What is the volume of the base that we are given? 28.7. 28.7 cubic centimeters. Whereas the molarity of the base is given as well, 0.15 mole per decimeter cubed. So when you go through that, you need to find out now, where do I start from? I need to start from a known solution, a standard solution. This is a standard solution in this case. The base is standard. Why? Because its concentration is known. So that is where we start from. Determine the moles of the base. So the moles of sodium hydroxide here will be equaling to 0.15 times 28.7 times 10 to power negative 3. When I multiply by negative 3, it is the same as dividing by 1,000, because the volume has to be in liters. Your calculator, please. You need to have, so now you need to press that one. 0.15 times 28.7 times 10 to power negative 3. So what are we getting? 4.305 times 10 to power negative 3. So these are the moles of the base. We need to calculate the number of moles of the acid. And when we're calculating the number of the acid, what do? As we did in the previous question, we need to look at the reaction ratio. This is 1, this is 3. So that means that the moles of phosphoric acid from this reaction is a third of the sodium hydroxide. That is from the reaction. So meaning that the moles of sodium hydroxide in the reaction that reacted will be equaling to 4.305. These are the moles of the sodium hydroxide times 10 to power negative 3 divided by 3. And when you divide by 3, press your calculator. What do you get? Mine is here. You should be having yours as well. And we press together so that we see whether we can get the same answer. Divide by 3. I still have the answer. 1.4, that is 1.435 times 10 to power negative 3. These are the moles of the acid. These are the moles, sorry, I think I made a mistake here. These are the moles of the acid, moles of phosphoric acid. Because that is what we are looking for. We are comparing this and this. So this must be phosphoric acid. So these are the moles of phosphoric acid. So now we need the concentration. Number of moles, which is 1.435 times 10 to power negative 3, divided by the volume. Do we have the volume? The volume is over here. So we are dividing it by 25 times 10 to power negative 3. As always, those ones will have to cancel out. So we remain with 1.435 divided by 25. Your calculator once again. So that is divided by, you'll have to 1.435 divided by 25. What do you have? So this is 0.0574. Capital M, that is the molarity. When we can use capital M, or we can use moles per liter or moles per decimeter. So all the same that we need to work out. So this is determination of water of crystallization. So we have one question over there. 3.9 grams, 3.92 grams of the sample of the hydrated sodium carbonate was dissolved in water and made up the total volume of 250 cubic centimeters. Of this solution, 25 was titrated against 0.1 mole, so the reaction is very important as well. So you need the reaction ratio as well. So you have the reaction. We have sodium carbonate reacting with hydrochloric acid, as we have mentioned, because we had this question even earlier. This gives sodium chloride, that is 2, plus carbon dioxide plus the water. So you need the data as you extract the data from the information. 25 of this solution, that is the sodium carbonate. So that is the volume of the carbonate. 25 of this solution was titrated against 0.1 molar with sulfuric acid. So we have the volume of the carbonate, which is 25 cubic centimeters. You have the volume of the acid, which is indicated as 27.4 cubic centimeters. What is the molarity of the carbonate? Because that is what we are looking for. We are looking for, are we given the molarity of the carbonate? The molarity of the carbonate is not given. But we are given the volume of the acid that was needed. So the molarity of the acid, that was required was 0.1. So here we don't have the molarity of the carbonate, so we need to find it out. So here you can determine, first of all, you need to determine the number of moles as we did here. That is what we are doing. 0. So you have moles here, which will be equaling to 0.1 times 27.4. Your calculators, please, are very important. As I write, press your calculator. Those are the moles of the carbonate, Now you need to find the moles of the acid. Moles of acid, I mean this. So we have determined these are moles of acid here, moles of carbonate. Next here, what do we get? So from the reaction, we started with the acid. So the moles of the carbonate will be a half. So this will be 2.7 times 10, 2.74 times 10 to power negative 3 divided by 2. So that is the answer that you need. So when you press the calculator, 2.74 times 10 to power negative 3 divided by 2. What do you get? 1.37. 1.37 times 10 to power negative 3. You get the moles. So after getting the moles, those are the moles of the carbonate that reacted. So what do you do? These moles of the carbonate were in 25. So you need to find the moles in 250. So moles of carbonate in 250 cubic centimeters. So this will be equaling to, so we said 25 cubic centimeters contain 1.37 times 10 to power negative 3. What about 250 cubic centimeters? 1.37 times 10 to power negative 3 over 25 times 250. That is, if you look at the number of moles, then you can get the mass. When you get the mass, then you look for the molar mass and then finish up. Dear students, thank you so much for being with me, but please, you need to finish up that one. Make sure you finish up that question from where we have stopped and the instructions that I've given. Look for the number of moles there. Look for the mass, then molar mass, then equate to get the value of X. We will be able to meet and even complete the question. Thank you so much. Hope to see you in the next lesson. Bye-bye.